Please mute your microphone. Okay, good evening, guys. I think I am visible and audible to you. Let me give me the confirmation. Hello, 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 guys. Hello.
Yes, sir. Visible and audible.
Visible, audible. Thank you. Yes. So I'm sharing my screen, right? Please confirm that whether it is sharing or not. My screen is sharing. Confirm, please.
Yes, yes, but not clear.
Yes, yes. It will be clear. Okay. So first of all, we will start with that assignment problem. Actually, I planned that I'll go through some important points regarding the previous lectures, but I think considering the experience of the previous classes, I think better if we cover the assignment problem first and then we'll go through the important details of the previous lectures. So first I planned this way, then I changed my plan. So this is a duration. So first this problem, right? So I think this is visible to you, right? Hello.
Yes.
Yes, yes, yes. So the packing density, the what it says, the packing density, right? Packing density. So I am visible to you, right? Hello.
Yes, yes, visible.
Visible, and also my screen is also, you can see my screen, right?
Yes.
Yes, yes. So actually the packing density is the single size sphere. If you consider the single size sphere, packing density will be lies between 0.52 to 0.74. How it is possible? So the thing is, I have noted something. Yes, actually, the packing, the packing density is the VB by VS by V. is a volume of solid by total volume. So this is the packing density, and if you for the simple cubic structure, so this is the 0.52, and for a body centered cubic it is 0.68, face centered cubic it is 0.74. So what are these simple cubic packing is very simple. So you know, very simple, that means if you yes yeah, if you just I'm just editing one slides, adding more slides and trying to sorry okay. Actually I'll use this. Okay. Okay. Actually, packing density, right? So packing density means packing density is nothing but Vs by V, volume of solid by total volume, right? So is nothing but Ia. So and if it is total volume is V, so Vs plus Vp. V means volume of force or volume of voids. So if I divide it by this V, then it come 1 Vs by V, Vs by V by Vp by V is the porosity. Is volume of pores by total volume is the porosity. So I can write is like the P. So Vs by V is equal to 1 minus V. So this is the packing density. I am just in abbreviated for PD, packing density PD. So Vs by Vz. So how the simple cubic packing, what does it mean, the simple cubic packing? Simple cubic packing nothing but this is the cubical structure. This cubical structure. This is, here are the particles, right? Particles. Actually, in a microscopic view, they are very small. I am just enlarging it for the sake of understanding, right? For the sake of understanding. So this is a simple cubic structure. So it's called the simple cubic structure. Okay. And how the, now how this Vs and Vb all the calculated. So Vs actually here we assume the particle is round sphere, and this is here, and the cubic is like this. So this is a simple cubic. This is the particle. This is the particle, and this is the surrounding arrangement. This is the surrounding arrangement is this cube side. So the and these are the voids. You know, this is the voids leaving the space, the solid volume. So Vs is nothing but 4 by 3 pi r cube. So if I just enlarge it, I'll quick it. If I just enlarge it, so this is the yeah, this is so sorry. This is the dia D. This is the dia. Is the cubic. This is the R. So this is Vs. So this portion is Vs. So Vs is pi r cube. So it's nothing if I express it with d. So pi d by d by 2 cube. So it's nothing but pi pi d cube by 8. So it is nothing but pi d cube by 6 is 6 pi d cube by 6. So now the total volume is dq. You know the simple cubic structure. It is if a simple cubic is there. So you know the one side is d. So you can easily calculate the total volume. So it is vs by v. So pi dq by 6 by dq. So it is pi by 6. So pi by 6 around 0.5. You can check. Is I can check with my is pi by 6. See 0.52. It is coming 0.52, right? 0.52. So this way the simple cubic form. Now body centered cubic, how does it look like? Body centered cubic. Body centered cubic is the yes, body centered cubic is nothing but these are the particles. First I'll write the structure. Okay. Body centered cubic. So here particle is there, here particle, here particle, here particle, here particle, and in between this particle. So it is like this structure. So these particles are connected to this center. So it is the body centered. So in between, in the middle of the cubical structure, there is also one particle. So this is the BCC. So considering this arrangement, you can obviously understand the BCC packing density is more. So this calculation is little bit tricky. So I'll not go to that calculation. So it is around BCC packing PD packing density is 0.68. 68. So 0.6. Sorry for my handwriting. So now the what is face centered? Now the face centered the single volume. So all volume are V. So this volume are V. This volume is V. All volume is V. But however, you are seeing that in the same volume, the particle number of particles getting increased. So that's how it increasing the packing density. So whenever the packing density is more, paste consumption will be less. So paste consumption will be means for hydration or anything else, to combine all these particles, the paste will be less because their packing is dense, right? So the now is FCC. FCC is this one, this one, this one. So all the all the eight corners, the particles are there. However, in addition to this particle, in each face, one extra particle is there. You know, yeah, extra particle is, and these are connected. Yeah, so these are connected. So that's how in each phase. So there are eight particles. Eight particles.
Echo.
Echo is coming.
Yes, sir.
I think my microphone on the other device is the device I am working with is blocked. So I think some other person might have on their microphone, and due to that reason you are getting the echo. From my end, I am not getting any echo from my end. If there is echo, I can directly hear that. Okay.
Okay, sir.
But I think some of you guys has think opened your microphone. Please switch off your microphone for better hearing. So this is the FCC, and particles are more dense. So see, there are besides there are 8 particles. The in each phase there is 6 phases, 1 2 3 4 5 6. So 6 phases is there. So in each phases one particle is there. So actually in the next class I will tell you how it is calculated, and if the time permit I will tell you. Okay, so the for FCC this packing will be more. The packing density will be more particle is accommodated in a same volume V. So its packing density is nothing but 0.74. So all the cubic, all the structure in the cement lies in between from simple cubic to FCC, face centered cubic. So at each phase the particle is there. So in between it lies. So for a single, actually these are all single size aggregate. Single size means there is no other aggregate, other size. So they are all single size. These particles are all single size. So all particle dies D, if I assume. However, it is not possible to for good packing or construction purpose. There is also grading. The grading should be there to fill the pore spaces to make a compact composite. So we in the most of the cases or if there is a single size particle, there is no other size particle mixed up with it. So for that case, always lie from simple cubic to face centered cubic. So always lies between for any single size particle, PD packing density lies between 0.52 to 0.74. So it with this it covers the first question. So now I'll go to this. Okay, so yes, this fine. So now is the if E is the void ratio of the binary mixture of the aggregate, what will be the packing density? So it is easy to understand how it is calculated. So E is nothing but I will draw this here. E is nothing but is void ratio. You see VB by V. Sorry, I think this platform is not good for. Okay, so I'll shift this here, this board. So E is nothing but VB by VS. Okay, so so the question is yes, how the E is related to packing density. So yes, yes, yes. So that porosity is nothing but porosity. So porosity is nothing but porosity VB by V. Okay. So you know this. Okay, fine. Let it be. Okay. So Vs by V, so Vb by V, so Vb by Vs, so Vb is nothing but V minus Vs by Vs, so V by Vs minus 1, so that is the void ratio. So void ratio is volume of voids by volume of solid. So volume of voids is nothing but total volume minus volume of solid by volume of solid. So it is VB by it is VB by V by Vs minus 1, right? So I can write V by Vs, V by Vs equal to 1 plus C. Now I can reciprocate it. Vs by V equal to 1 by 1 minus C. So it is by packing density. So with this it covers the first question. This question, this one. So this one. So it is 1 by this. So now for a binary mixture, which of the following is true for packing density? Packing density increases with the addition of second size particle. Packing density decreases with the addition of second size. Packing density increases initially but start decreasing after a limit. Yes, that is the true point. Actually what happened, actually there are two cases. If you for binary packing system means there are two size particles, only two size particle, one is small fine size, one is coarse size. First is you add the binary system, you add coarse particle with fine particle, and you are getting one void or void ratio or E value. And if you from the void ratio you can easily calculate the packing. Actually packing is nothing but you understand, this is the reciprocal, or is not reciprocal, is inversely proportional to void ratio. If the void ratio is the maximum, then packing density is lowest. Obviously packing density is lowest. So with the graph we also come to that point also. What is the packing density? The packing density is the void ratio is maximum, is least, the packing density highest. So from the graph we can come to that point. So and another point is the you add one fine coarse aggregate is there, one volume of coarse aggregate there, and you add some fine aggregate. So there are two possibilities how you mix the two aggregate. So actually there's a little deviation, I'll come to that. And the packing density increases initially high but that start decreasing. So actually what happened, if you add, or if you, yes, if you yes, yes, yeah, first of all, if you add the secondary particle, then the packing density will be more, because one large size particle is there. There is no space, so I have to erase it. If you there is large size particle, and if you add the secondary particle, then the packing density will be more. However, if you add more secondary particle, the fine particle, then what happened, there the particle interference will come. The particle interference, what is the particle interference? Now there is two particle interference, is the wall effect and loosening effect. Wall effect means the increase the void ratio in fine particle, right? Increase the void ratio in fine particle. So then fine particle, how the wall effect works, if there is a large particle, this is a large coarse aggregate. Actually these are the microscopic view, I am just enlarging for the sake of understanding. So so if you check if you check these are the small particle, the small particle, small particle, these are small particle, these are the small particle, the small particle, right? Actually if this area is see this is the surface, and now the surface the specific surface is less. If it is straight one, the specific surface is less, then there is some angularity, then more particle will come. in contact. So so based on the surface, the particle are attached with each other. If there is angularity, the more particle will come. If there is a flat surface, so the particle accumulation will be less in that portion. If you add more fine aggregate, then what happened? This wall effect will come. So there is a this is a wall effect. The wall effect will come, and after a certain addition of particle, this is the interstitial spaces. This is the interstitial spaces. So these spaces will get increased. Spaces will get increased, and this lead to this discreteness. This led to disintegration, or not disintegration, the separation of these small fine aggregate from this um, coarse surface. So it is due to the wall effect. The loosening effect, what is the disturbance of packing or a void content in coarser particle. So coarser particle is see, these are the coarser particle. The coarse particle is there. Coarse particle is, this is the coarse particle. Then I add. See here have what happened. Here happened yeah, the coarse you adding any fine particle is secondary. This secondary with coarse. Now now I can change the color little bit. Okay, I can change the color. This is the this is the fine particle, right? This is the fine particle, right? So yes. Now when this is a wall effect, right? Wall effect. And now what is the loosening effect? Now adding sorry. Actually, with this you can't say what is the secondary and what is the primary. Actually, this is the wall effect, and is nothing but it is like a phenomena. It is like a phenomenon. You can't say that this is the secondary, this is primary. You can't say this is a secondary, this is primary. So I can't say this is the first is coarse aggregate is there. You are introducing the fine aggregate. No, it's not like that. The effect is the effect comes only after adding either of the two, either of the coarse or either of the fine aggregate. If you're adding, so it is just focused on the effect. How if you add either add coarse aggregate, either or fine aggregate more than a certain limit, what happened? So the two things can come: loosening effect or wall effect. It can be in combination. So adding fine, so I just remove it. It's not good to say. So this coarse aggregate is there. You are adding the fine aggregate here. Now what happened? Actually, if you keep putting more aggregate, if you if you keep on introducing more fine aggregate in the interstitial spaces of the coarse aggregate, what happened? It will push this coarse per particle. It will push the coarser particle. It will try to push them away. So the coarser particle now become it is become separated. Okay, so this how this and this way it increases the void content in the coarser particle. So this way it defines the effect of particle interference if you add either coarse aggregate or fine aggregate above a certain amount. So what happened? first, if I draw this, the packing PD is there, and this is the volume fraction, VF, volume fraction. Volume fraction is there, where is two particle is there, particle A, particle B. Here the particle A is the zero, or here particle B is the maximum. Here particle A is maximum, B is zero. So what happened? Actually, it first of all it goes, then it came down because of the particle interference. Actually, this is the most idealistic case. However, in the practical case, it is like that. This transition will be smooth, not a peak one. Okay, and it is the real case, and it is the ideal case. So nothing in world is ideal. So here is the yes, this is the peak, maximum packing density. So first it increases, then decreases. So with this it complete that question. Okay, whatever. Okay, now now this first I have to, yes, to change this, yes. Now now the next question is, yes, now the next question is, if for single size particle of size 300 micron, fineness modulus will be what? So it is nothing but okay. So this, if you check the sieve, so if you check the sieve, then bottom is 75 micron, then top is 150 micron, 300 micron, 600 micron, 1.18 millimeter sieve, 2.36 millimeter sieve, 4.75 millimeter sieve, and is 10 millimeter sieve and 20 millimeter sieve. This is the chronology of the sieve analysis. The sieve analysis we do for grading of the aggregate for the mix design purpose. So most of the fine particle will retain in this 75 micron. It is above 150 micron. If it actually if you see the sieve, these are this size. So this size is called this size of the sieve. If one aggregate is just stuck in between, so it is also included in that category of the size. So if it is stuck in 150 micron sieve, then this size is 150 micron. 150 micron is nothing but 0.15 millimeter. It is 0.075 millimeter. So this way. So this is the fineness modulus. Is nothing but a weighted average, right? Weighted average sieve number, right? So actually cumulative percent retained in all sieve. So I'll come to the next question. So what is the this is the yes, actually if you see that it is nothing but this sieve number is sieve is 0, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6. So our point is 300 micron. So 300 micron is 2. you also verify what I am doing is right or not. You also verify from your end. Okay. Anything I am telling you, if you have some objection, you just raise your hand and I will just address it. Okay. This is the maybe maybe I am saying wrong. If it's not there, maybe I am saying wrong. But you have to be careful about all the whatever I am doing. If there is anything wrong, you please raise your hand. Say, okay, you are maybe there are some changes. So that is my expectation from you guys. Uh, so. Um, 300 micron, so this is the 2. So it is finest modulus is 2. So I have also noted this way. So for 70 micron is 0, 151, 302. So with this it complete the fourth question. So now the fifth point is the what is the following property of aggregate is related to volume change due to weighting, drying, thermal and frost action. These are all related to the soundness. Yes, soundness. So soundness is nothing but the volume change. Volume change. Actually, I have also attached a few questions regarding the previous lectures. I don't know whether you have solved those questions or not. I'll solve those questions in front of you or together with you if in today's session. Okay. I think I am visible to you, right? I think I am visible to you. Okay. Yes, I am visible to you. Yes. This is the sound. The following property of the aggregate is related to volume change due to wetting and drying, thermal process. This is soundness. So see, actually you are not seeing my page because I am sharing this my tab screen. So I'll share all the related material in the folder folder file. If you go to the Teams, Concrete Technology Teams, so you'll easily find the file folder. Inside the file folder, I will upload all the relevant files for the ongoing sessions for this semesters or the classes. So you don't have to mail me or you don't have to ask me for sharing the materials. So I'll just upload it and you please check. And also please don't request me for sharing your attendance list because I can't give you the attendance list. So please don't yeah, request me, okay, for sharing. So now the sixth question is calculate the specific surface in centimeter square per centimeter cube. So this is nothing but what is the area by unit volume. Okay, calculate the specific surface centimeter square centimeter cube for a given grading of the rounded aggregate. So this is the what they are saying. Mm, what they so so this is the C. Okay, so this is the C. Okay, so this is the C. Now sorry, no, this is the C. I have to again laboratory. Okay. Okay, so this is C is there, it is in millimeter. Passing, what is the percentage passing? Percentage passing by mass. Okay, okay, so first is 20, 100% is passing, 10, 75% is passing, and what is the amount retained? 25% is the retained. So you easily can calculate, right? So you don't have to be, look for others. So it is simple, very much simple. So 4.75, it is 40, 40. So 40 passing means 40 is passing means 60 retained. 60 retained, already 25 is retained. So 60 minus 25 is nothing but 35%. Okay. Yes. Yes. So this is 35. Now if I go to 2.36, 2.36, so passing is what? Passing is 35. Passing is 35. So now 1.1 is the passing. What is the 30? Passing. Now now 0.600 micron, 0.6, 0.6 is there, so 25 is passing. 0.3 is there, so what is passing? 10% is passing. Now 0.15, 1% is passing. Okay, now if you add, yes, okay, now this is okay, the point 2.36 millimeter, this 35% is passing. So 35% is passing means how passing means how much it retained. 100 minus 35 is 65 is retained. So already 25 and 35 is 25 is retained by 10 mmc, and 35 written by 4.75 mmc. So so 60% already retained. So minus is 5. So 5 is percent is retained. Similarly, if you check here, then 30 is passing. So 70 is retained. So 70 is retained, minus 70 minus already retained how much? 65 is retained. So it is 5. So 5% is retained. Now 600 micron, 25% is passing. So 75% retained, right? 75 minus already retained what? 5 minus 5 minus 35 minus 25. Okay, it is 5%. So you understand, right, the concept. So 75% retained, so minus 5 minus 5 minus 35 minus 25, this is 5. So now 10% is passing. So 10% is passing, how much is retained? 90 is written, right? 90 is written. So 90 minus, or how much is already written? Minus 5 minus 5 minus 5 minus 35 minus 25 is 15% written, right? 15% written. Now is 1% passing, 99% written, right? 99% written. So 99 minus 15% already written, minus 5 minus 5 minus 5 minus 35 minus 25, this is 9% is written, right? So if you add all this percentage written, how it should be 1. So we check 25 is coming, 25 plus 35 plus 5 plus 5 plus 5 plus 15 plus 9. It is coming 1. 25 plus 35 plus 5 plus 5 plus 5 15 plus 9. It's something wrong. 25 plus 35 plus 15 plus 15 plus 9. Okay, it's 1. Actually, okay. Okay. Oh, okay. Yeah, okay. 9 and 1% is retained. So in the if you check by 75 micron, 75 micron, actually 75 micron, 0.075. This is no pass, so it is 1% is retained. 1% retained. So 1% is passing means 1% is retained. Okay. So it is not 1. So it complete is 100, right? So 100%. So these are the fractions. See, these are the fractions means this is the fraction 25% is the fraction of the aggregate retained on sheet size of 10 mm. This is the 35 fraction written on 35% written on 4.75 mm, 5% written on 2.36, like so on. So this is the this how it calculated. Now what is the formula? Yes, the formula is for a specific surface. So what is the specific surface? Is area by volume. So for the specific surface, specific surface that for the two particle written on 0 and written on 0 ship and written on 1 ship. So this is the 0 ship, this is 1, this is 2, this is 3. So like this one. So it is like specific surface C01 is nothing but 6 by, you can easily remember the formula, right? So I've already mentioned this. So actually 0.0075 and 0.015. Why 0.015? Actually you have to calculate in centimeters first. So centimeter is 1 centimeter, means 0.1 1 centimeter 10 millimeter. So based on the calculation, it is 6 by 0.0075. I just convert 75 micron to centimeter, and I am getting how much? How much I am getting? 53354 is 5. I guess I am getting 533. Okay. Centimeter square by, so sorry, centimeter square by centimeter cube. Am I right? Okay. Similarly for C 1 2 you can easily calculate. So with this the formula comes specific gravity of all aggregates, specific surface for all aggregate is nothing but 53333 by here this yes 0.33 by P naught P1 by 2 P2 by 4 P3 by 6 like so on. Okay, so it is nothing but it is P0 plus summation Pi by twice I is 1 to n. So this way it forms. So here what happens, here I am just string 53333.333 into this fraction. What is the fraction written in P0? This is I have to show you. This is the P0, P1, P2, P3, P4, P5, P6, P7. Okay, P7. So P8, P is nothing 0 because no percentage is written. Okay, so P1 is there. So here you can't say in a percentage 1 to 9. No, you have to make it a fraction. So 0. P0 is nothing but 0.01. This is 0.01. So 0.09. Yes. Yes. 0.15. 0.005 0.35 is 0.35 0.25. Okay, so yes, so you just simply add, there is no big deal, there is no big deal. So 0.09 by 2, 0.15 by P1 this is 0.15 by P2 by 4 P3 what is P3? 0.005 by 6, right? 6 no? 6 0.005 by, sorry, yeah, I'm doing wrong. No, we'll continue. So okay, 0.05, right? 0.05, yes, 0.05. 0.05 is 0.05 0.05. Okay, 0 point P6. What is P6? So P2 is 0.15 by 4. P3 is 0.05. Okay, first I take the attendance. I did forget the attendance. Okay. Hmm. 0.05 by 6, this is P3, P4 0.05 by 8, P5 0.05 by 10, 10 is by 10, 0.35 by, sorry, 0.35 by 12, 0.25 by 40. So if you calculate this total sum, you will get 8485.71, 8485.714 unit. What is the unit? Centimeter square by centimeter square. Centimeter square by centimeter square. So this is the total calculation. So I will also make some text over the PPT. I'll share with you. No issue. You will find it in file folder. Okay. Uh, so the next question is, now the specific surface has been calculated. Now if you go the fineness modulus, with this it covers the 6 question, right? Yes, 6 question. Now the fineness modulus. The fineness modulus is nothing but fineness modulus. Fineness modulus is nothing but percentage cumulative retained by 100. So it can be it is a one way of expressing the fineness modulus. Another way of expressing the fineness modulus is, actually fineness modulus is nothing but to find the average weighted sieve number. If you actually in the concrete mix, we are not mixing a single size aggregate. We mix a graded aggregate. There is some grading is there, so that our the composite or the concrete will be more dense and more it will have more strength. So that's why the grading is done, so that is there any void space, it will be filled by the finer particle. So that's why the grading is done in the mixed design. So if fineness modulus nothing but to find the average sieve number, average sieve size. What is the average sieve size or average particle size? So this way you can you can think of, or you can visualize, or you can think the fineness modulus. If you just stick to the formula, you will be bored one day. That what is the formula, I'll just memorize it and deliver in the exam. So if you do that way, you will get bored after some time. So if you go if you think the concept, then it will be easy for you to remember all the formulas. So it is nothing but the average sieve number. Okay. So it can be calculated this way. This is the one way, and another way you find the sieve number. So Fm is nothing but P0 into 0, P1 into 1, P2 into 2, this way. So okay, so already I told that P0 is nothing but P0 is nothing but the percentage or fraction written in 75 micron. This is 75 micron, this is 150 micron, this is 300 micron. So this one, this way it goes on. So what is the yes, what is the P0 fraction? What is the P0? I think yes. P0 is nothing but 1%. 1%. So 0.01 into 0, 0.09. P1 is 0.09 because 9% written. Actually, I watched it. Actually, I removed the. Okay, seven. Actually, I remove right. So I have to again make the table and we have a better understanding. 100% passing. Passing SIM number 10. 2.36. 1.18. 13. 0.6. 24. 0.3. 10. 0.15. 1. So what is the return percent return? 25%, it is 35% return is return 35%, 15% is written here, 5% written here, 5% written here, 15% written here, 9% written here, and this is a small amount 0.075, 75 micron, 150 micron. It is 1% return. Okay. Now if I just add in this all this, okay, so this is P0, right? P0, this is the P0, P0, P1, P2, P3, P4, P6, P7. Okay, so I'll better write here. No, you will find it. Okay, so you can see my screen. So P0 is 1, 0.01, 0.01 into 0. P1 is 0.09 into 1, the first shift. 0.15, 0.15 into 2, 0.05 into 3, 0.05 into 4, sorry, I think I have made some mistake. 0.25. Yes, this is not a 15, this is 5. 0.05 into 5, 0.35 into 6, 0.25 into 7. So with this it counts 4.84. Okay, if you calculate it now.
if I can cross verify, I can verify another way. So what is the cumulative percent retain on each sheet by 100? So yes, by 100. So what is the cumulative percentage then? It's nothing, first is in each written in each sheet. So cumulative percent is in the P7 sheet. P7 is nothing but P7 25. Okay. 25 cumulatively written in P7 SIP, 10 meter SIP, cumulative return to 4.75 mm. How much written cumulatively? It is 25 plus 35, because at each SIP you have to add the, if you are finding the cumulative number, then the retention of in that SIP, that will be included, as well the SIP above of it. So all the percentage retained will be added for cumulative retained at that SIP only. So for the SIP number 4.75, what is the cumulative retained? That is 25 plus 35, that is 60. What is the at P5 2.36, what is the written cumulative return? 65. P4 1.18 70. 600 micron 75. Okay. Now 300 micron, what is 75 plus 15, what it is? 90, right? 90 plus 15 150 150 micron, how much written? 99. Now in 75 micron is 100, actually 100. So it is now by 100 total. It's coming 25 plus 60 plus 65 plus 70 plus 75 plus 90 plus 99 plus 100. Okay, I'm saying I made something wrong. No, retain. Yes, actually I have to I don't include this section because this section is not in your question. So I only restrict my calculation to 150 micron. So 150 micron, it would not come, this 100% would not come. So up to, if it is there, if it is in that that in question, then it will come, right? So here 99. So 4.84 it is coming, 484 it is coming by 100. You can easily calculate it. So it's similar to this. Sorry, I actually I erased it. So yes, actually I erased it. So previously it was if I calculated by P0 into 0, P1 into 1. So with it and with this formula, it is the same. So you can verify your calculation. So both are same. So with this it completes the 7th question. So now actually now what I'll do, I'll discuss few points regarding the previous lecture. Okay, I think in the previous class, previous session, actually I made some mistake regarding the answers. But, however, I also corrected those answers and attached the files in the uploaded the file in the Teams. I think you have got the access, because there is some mistake in the some questions regarding the angularity and sphericity. So actually I made some mistake. I'm sorry for that. So I think that is the correct answer for all the questions actually. So I'll discuss in some time, because now this session is dedicated for solving the current lectures problem. So if get times in between, I'll discuss those questions if that on that I made the mistake in the previous class. So okay, so I'll in between, if I get time, then I'll discuss those questions, no issue. Okay, now the thing is, actually I am not going through all the lectures. However, I will discuss few points that I think you may have some difficulty in understanding the concept. Okay, that is also the purpose of the current session. I already mentioned. Yes. Yes. Uh, now, now if you check the lecture 7, if you go to the lecture 7, where Professor Bhattacharya has taught you regarding the aggregate, its fineness, its packing density, that is relevant for the kind assignment questions. So all are taught in the lecture 7. Okay, aggregate casting value test, impact value test, abrasion test, also there is some SSD condition, moist condition, air dry condition. Is also go through all the concepts. Okay, lecture 7. Lecture 7 and lecture 8, including lecture 8. Okay, so so I'll just I think he haven't show you how the equations are coming regarding the binary packing of binary system. I already told you the I already told you that the binary system, whenever the binary is coming, there is a two particle size, one is coarse and one is fine, and there is a two way you can mix up all the particles, right? You can mix up all the particles. Okay, so yes, so this is the packing of binary packing of binary system. Okay. What happened here? The first focus, adding coarse aggregate with fine aggregate. The fine aggregate is the A, or coarse aggregate is the B. Okay, coarse aggregate B. So assume this fine aggregate is there, right? Okay, now the coarse aggregate you are adding, so you are adding more volume. Okay, I'm just for the sake of understanding, I'll do it in different color. Okay. Okay, I'll do it different color. Now this yes, these are the B. As if this is all the B. So so this is B and this are A. So this particle is there, and you are adding the adding the coarser particles. So this is the volume V. Now this is the volume excluding the B. Okay. Now volume BB. Actually, the volume V. Volume B is the bulk volume of A, including the voids and solids. Okay, V is nothing but VSA by VA, volume of voids. Okay, and so you are adding volume to this total quantity by introduction of B. You are adding more volume. So and considering the fraction, volume fraction, how much volume fraction you add in the total composite total arrangement of the volume fraction of B. The volume fraction of B is X, and B is nothing but B SB, but SB means solid volume of B, VSA plus VSB. Okay. So at certain point of time, so there is the EX. So EX is the void ratio. Sorry. EX is the void ratio. What is the void ratio? Void ratio formula you already know. Void ratio is VB by VS. VB by VS. VB by VS is nothing but V minus VS by VS. So V by VS minus 1. This is it. So volume, total volume by volume of solid minus 1. So is the E. That is, you can also say E. So EX is nothing but after adding the V, the total volume is there plus VB. VB, not V, it also is VSB, solid volume of B. VSA by VSB minus 1. Okay. now here the derivation comes. How it arrives? You already know the formula. EA minus 1 minus X. EA is nothing but V by VSA minus 1. V by VSA total volume of the bulk volume of A by solid volume of A. Right? So how it is arriving here? So I think Professor Bhattacharya has covered this part. I think. So we'll be doing here. Okay. So you just make a so VB plus VSB minus VSA minus VSB by VSA plus VSB. So VSA, you just cancel it out, so it comes V minus VSA by VSA plus VSB. Okay. Now what you do, you divide by VSA. Okay, V by VSA. So numerator denominator you divide with VSA. V by VSA minus 1. There is no mistake. Okay, V by VSA. Yes, V by VSA minus VSA by VSA VSA by VSA. You just divide the numerator by VSA. Okay, plus VSB by VSA. Yes, this is cancelling out. How it's coming? So V by VSA minus 1 1 plus VSB by VSA. Okay, is VSA. So it's nothing but this is the this you already know. This is the EA. This is the EA. And now I can manipulate with this expression. This expression. How I can manipulate it with this expression? So this is the x. So what is the x? X is nothing but VS, the volume fraction of the x is nothing but volume fraction of B. VSB by VSA by VSB. Okay. So if I reciprocate it, 1 by x equal to VSA by VSB by VSB. Okay, then I just VSA by VSB plus 1 VSB 1, just divided. Okay, so VSA by VSB equal to 1 minus x, 1 by x minus 1. So you can do one thing, 1 minus x by x. So VSB by VSA is nothing but x by x minus 1. So I will remove this. Okay, so I'll just put it here of VSA by 1 plus x minus 1 minus x. So EX, it will go top when it is 1. So EA. So with this we complete the derivation of the this this equation. Okay. Yes, this is binary packing system. And this what is the binary packing system? If it is binary packing, and if the coarser aggregate is added in the fine aggregate arrangement, then what is the void ratio? When the small amount of coarse aggregate added to the fine aggregate, so it is a small amount. Whenever you are adding, it is small amount, so that you can identify the changes. Okay, so it is nothing but Ex equal to EA 1 minus x. So the derivation, that chronology you already understood, I think. So and now if it is the small amount of fine aggregate added to the coarse value, so it is like this is the coarse aggregate. Now here will be no volume change. In previous cases we are adding the more volume to the fine aggregate, so it is we have VB is we are adding VB, it means the volume of solid. Now there will be no volume change. Okay, so the volume change will be V. So here the coarse aggregate is there, and the fine aggregate. And fine aggregate is in between. Okay, so small amount. So with this, if I calculate the E, bulk volume will remain same. So total volume, total solid volume is total solid volume. Okay. Total solid total solid volume is Vs equal to Vsa plus Vsb. Now Ex means after adding this coarse aggregate into this fine aggregate element, so Ex is equal to nothing but V by total volume V by Vsa by Vsb minus 1. Okay, for this total aggregate arrangement, binary aggregate arrangement. Okay. Okay, so and here the x is nothing but similarly the x is nothing but the volume fraction of the volume fraction of fine aggregate is nothing but Vsa by Vsb Vsa. Okay, so actually you can manipulate with this similar way. How can you do that? Yes, eb already you know. bb yes, v by Vsb minus 1. Okay, so we have to just make a manipulation. Actually you can do it. I'll try. If it takes long, then we'll ship another time. You can do one thing. V by Vsb by Vsa by Vsb Sb plus anyone can do that, no issue. A line. Okay, so okay, yes, so you just V by Vsb minus Vsa by Vsb minus 1 Vsa by Vsb plus 1. So this two give Eb Vsa by Vsb Vsa by Vsb plus 1. So now the volume fraction of A. Okay, the volume fraction of A, how can be included here. Okay. So I can do one thing, right? I can do one thing. So Vsa Vsb is there. So in x equal to Vsa by Vsb by Vsa. So okay, so I divide by Vsa by Vsb 1 plus Vsa by Vsb. Okay, so I do this way. So I think 1 by Vsa by Vsb x Vsa by Vsb. So I'll express the Vsa by Vsb in terms of x, nothing more. Okay, so I'll shift this here to here. So Vsa what am I doing? Vsa by Vsb minus VSA by VSB x minus equal to x. So I'll just keep it in the other side, right hand side. Okay, so VSA by VSB 1 minus x by x. So VSA by VSB x by 1 minus x. So I'll just keeping it here. Okay, EB minus x by 1 minus x, x by 1 minus x plus 1. Okay, so 1 minus x EB minus x, x plus 1 minus x. So 1 minus 1 minus will get cancelled. Right. So I think we are closing here. Okay, so 1 minus x EB minus EB minus x. So I think there is some mistake. No, plus EB is coming, right? Oh, isn't it? I think I am right, right? EB EB minus x 1 plus EB. I think I made some mistake. Yes, VSA by VSB, you just go here and VSA by VSB. Okay, fine. VSA by VSB VSA by VSB minus VSA by VSB 2x. Okay, so VSA by VSB 1 minus x. Yes, VSA by VSB is 1 minus x. Then VSA by VSB x by 1 minus x, you just substitute here. Okay, if you substitute here, substitute in here, VSA by 1 minus x is fine. It's coming down. This. I think we have to check it. I think we have to check this equation. Actually, as per the Professor Bhattacharya, it should come like Ex equal to x 1 plus EB EB Ex equal to x1 plus EB minus 1. It should come, but it is not coming here. So I think I made some mistake. So this way you can do on your own. I already showed the first case. This is the first case. We are already it goes when fine. But however, in this when you add the fine with course, then I think I am made some mistake here. So I'll check it. And you also do on your own. Maybe in the tomorrow in the coming classes we can solve this problem. Okay, so you check it. Actually whatever you do, you have to find out this ratio in terms of x, and you just substitute it. There is no big deal in it, so there is no big deal. Okay, so I think the time is going, so I better I kept it aside. I keep it aside. Now I go for, actually the main thing is I want to discuss some relevant part or the previous classes lecture that will also help you understanding the problem, understanding the behavior. Okay. Okay, so actually the thing is this this velocity and this in the lecture 6, that is the sphericity and angularity is there. So that question I did wrong. Actually there was a mistake from my side. Sphericity is this is right. So sphericity is for the sphere. Actually for the sphere, actually it is coming by pi 1 by 3 6 Vp by 2 by 3 Ap is nothing but this particle. Okay, the AP and Vp is nothing but the volume of the particle, and area of the particle, surface area of the particle. The surface area is the volume of particle. So this way it connect, sphericity is connected. Now the angularity is the angularity is the 1 by psi. Is just reciprocal. For the for the I think for the sphere, sphericity or the size 1, so angularity will also mean there is no angularity because sphere is no angular, so angularity will also be 1. And rounded aggregate sphericity is 1.1 rounded aggregate, 1.4 irregular aggregate, 1.7 crust aggregate. Okay, so you remember this. I think in the last class I made some mistake, and also there are some other mistakes I am forgetting this. So I'll in between, if I get time, I'll discuss those questions. I've already answered those questions. So
Yes. Actually, another point I want to mention regarding this volume fraction. Regarding this, regarding the void ratio and volume fraction, it is decreases. And actually, if I draw it, I'll quickly drawing it. Void ratio is there. Void ratio E is there, and volume fraction is here. Volume fraction. Volume fraction. Volume fraction where two particles is there, A and B particle is there, where here volume fraction is 1 0 0, A is 0 0 here, B 1 here. Okay, so if it is like that, if you add B, here is A side, it is A side, and if you add B in particle A, then it decreases, void ratio decreases, then increases. So also the increasing is because of particle interference. I've already told that void ratio and this packing density are interrelated. One is, if it is one decreasing, then one is increasing. Packing density obviously is a true fact. This is actually ideal. This is the actual case. Now this is the ideal case, and this is the point where you find the maximum, packing density or minimum minimum void you can identify. So similarly, this is equivalent, like it can be, again another way you can represent with the packing density. Pd is the packing density here, and for the A particle here, and where the A is the most of the part is A, 0 is volume fraction of B, 0 is A, and this side is 0. And if you add particle B with the particle A from this end, and it will first increase the packing density, then it is decrease. This is the real scenario, real case scenario. For the ideal case, it is like this. So you will find this. So at same point, at same volume fraction, you will get the minimum void ratio and maximum PD, packing density. So this is the concept actually. So optimal portion, actually this had some formula. Optimal proportion at which the void ratio is minimum is the x star, or you can just any notation you can use, 1 plus EA plus 1 plus EA by EB. EA in EB you already know the void ratio of A and void ratio of B. So it is like a EA equal to B by VSA minus 1, EB equal to V by VSB minus 1. So this way it calculated this X and you will get. Okay. So this I think this part is covered. Now another thing I want to discuss with you regarding this. I find difficult while understanding this the chart, and I also think that if I discuss with you, you will get more interesting. So regarding the regarding actually Pozzolana, why we add Pozzolana, if we add a Pozzolana in the cement, it will it will reduce the flash shedding property, increase the workability, all the factors are coming. So and also it reduces alkali aggregate reaction. So this way the Pozzolana reacts. The Pozzolana mainly derived from fly ash. It's like a fly ash is also Pozzolana, and also this silica fume. This is also one type of Pozzolana. Actually, when lime reacts with the clay, it gives a cementous material. So Pozzolana, yes. So yes, actually this is the way how this pozzolanic reaction occurs.
First C3S is there, and if you add water, hydrogen, water is there, then it from CSH gel plus calcium hydroxide, CaCH, calcium hydroxide. This CH is non-sealing precipitate. If you add more, if you add little pozzolana here, then this pozzolana will react with CH and it form. Actually, we are not getting the pure CSH here. So if we add pozzolana, then H plus CH means silica plus silica, it will, CH will act plus this water, and it gives the pure silica gel. There is no byproduct. So it is this equation is called this pozzolanic reaction. Pozzolanic reaction. Okay, this I have to say. So silica fume is a quartz, is a derived from actually I also mentioned all this in the PPT. I will share with you. The silica fume also pozzolana quartz heat up with 1800 degrees Celsius made the pure silica, and this pure silica is the fume. It's a gaseous form and it is get condensed, and after condensation it microsilica get formed. The microsilica is very strength, is a very has the potential for a high strength, for providing high strength in the concrete. So, and rice husk is also the pozzolana. If you burn it, then CO2 will evaporate, so it will liberate and leaving the siliceous and aluminous material is there. So, and now another part I want to discuss this. There's a different grading is there. So ASTM type 1, type 2, type 3, type 4, type 4, type 5, and also there is a white cement, pure cement, and also the expansive cement. Type 4 is the low heat cement. I also have the question. I also made some question regarding low heat cement in the previous class. Make some question. I think you have also solved those questions. So low heat cement means this is less C3S, more C2S. Okay. So white cement is the mainly decorative purpose, and expansive cement is used for grouting purpose, hole filling cracks. If it is shrinkage, if it is shrinkage there, then you can feel you can incorporate the expansive cement in the shrinkage portion, or the shrinkage compensating cement. So if you add the expansive cement, it will keep the water inside. So the shrinkage is mainly if the water dries out from the main structure, then it leaves some white spaces. With the pressure it get shrinked and the cracks are generated. So it actually prevent the expansive cement, prevent the shrinkage also. And with this it complete. Now the this chart comes where this is a pyramid type shape chart that I feel you also feel some difficulty if understanding. This is calcium oxide here, aluminum oxide, and this is SiO2. Okay. Actually, calcium oxide is maximum here. So if you go this side, the calcium oxide is maximum. If you go this side, this aluminum will be maximum. If you go this side, and so it silicon will be maximum. Silicon will be maximum. So if you consider that three parts: the Portland cement, slag cement, pozzolana cement. Okay. So if I say the Portland cement, Portland means this Portland is OS written here, is slag is here, and then Pozzolana is there. So Pozzolana is more silica content. If you can see, the Pozzolana is near to the silica, so it's more silica content, but less A2O3, less CO. However, sorry, you can say that if they are in the same line for the Portland cement slag and Pozzolana. Actually, I can say that this is Pozzolana. This is slag. This is Portland PC, Portland cement, Portland cement. So if it is in this, actually it is in the same line. So for all the three, A2 3 same. However, for the silica slag, actually the silica. The slag, the silica will be less. Sorry, silica will be more compared to this Portland cement. For the Portland cement, calcium oxide will be more as compared to the silica. So this way you can categorize the content of the cement. So with this it completes. I think today I am not getting time to discuss with that short type answer, that is multiple choice question. Okay, so actually now the 5 minutes left. Okay, actually the aggregate crushing value test is the abrasion is the impact value test is there. Actually you can't identify, you can get the result if you for the crushing test, or you can directly, you don't directly, actually there is no direct method of getting aggregate strength from a compound compound situation. If all are aggregates is there, you can directly find the particular test value on the aggregate, the composite aggregate in compound. So you have to individually test the aggregate, and you can to compare both the aggregate and get there and characterize all those aggregates. So first is the crushing value test. Crushing value is the first you have to make the material passing through 40 mm sieve, retain on 10 mm sieve. You collect the material overnight for 4 hours and crushed under 400 kilonewton in 10 minutes. This percentage of and you also sieve that percentage, sieve the crushed aggregate to 2.3 millimeter sieve, and a percentage of passing is recorded. If it is 25 to 30% means is good aggregate, 40 to 45% is not good aggregate. So actually there are also some points you also seen in the PPT that you have to increase the load to get the penetration of 15 millimeter for rounded aggregate, 20 millimeter for crushed aggregate. Actually increase the load means you have to increase the load in 10 minutes. So increase the load, and in 10 minutes if you get the 15 millimeter penetration, the plunger is there, 15 millimeter penetration is there, so it is the rounded aggregate. Okay, so and for 20 millimeter it is crushed aggregate, 24 millimeter is honeycomb aggregate. So this way how it calculated, and how it guessed the penetration crushing value or penetration value. And for the impact value, the same thing is there. The material passing through 40 mm sieve, written on 10 mm sieve is it's taken, and you do surface dry condition. Surface dry condition, first of all you make it a pure moist condition. Total saturation is there. Just make a towel on it and just soak the moisture on the surface and remove it. So it is the surface saturated surface dry condition. And then you put a hammer with standard height, standard weight, and you fall the hammer at the standard height 15 times under the self-weight, and passing, and the aggregate get crushed, and you pass the aggregate 2.36 mm sieve, and you get the fineness what is the finance value, what is the percentage passing. If it is 25% is it's suitable for the concrete flooring, 30% is for pavement works, and 45% for other works. So this is all are covered. So now the part is the plasticizer and admixture. All these things is there. So the admixture is nothing, the it gives the actually it adsorb on the chemical cement surface. It absorbs on the cement surface and make it a more workable. So adsorption is nothing but this is the particle is there, and if you adsorb the water, then the water molecule just make a film on the particle. So it is called absorption. Absorption. So if it is absorption means if you add the water, or if you get the chemical, the mineralogy or the chemistry or your composition will get changed. It is different. Your molecular reaction due to the chemical reaction, your the particle identity or particle composition will get changed. But in the adsorption, it is nothing but if you adsorb some liquid or fluid, it will just make a film over the surface. So it is called adsorption. So actually the what happened, if you don't add the admixture with the cement in the without admixture, the cement get flocks. This flocks due to the van der Waals force. And if you add the admixture, then what it happens, the there is a water reducing admixture is there. So if you add the WRA, water reducing admixture, so it is negatively charged. It has adsorbed on the cement's particle surface, and what happened in repulsion will take place. So repulsion means if you there is a cement particle, is a flocculation is there. So flocculation is cement particle is get flocculated. If you add the admixture WRA, if you add the WRA, then WRA will create the negatively charge here. So negative charge here. So negative charge will repulse each other. So it get deflocculated. After the deflocculation, what happened, it also make a sheet of water. This is also absorb the water here. So absorb the water here and make it a more workable, and lubrication effect is coming. So with the lubrication effect, it will be more workable. So the in this way the admixture works. It also there will be no strength deterioration. It will, and at the same time you will get the more workability. So there are the three process or ways in this water reducing or this admixture works. I'll just show. I think already time is already there. So the strength of see, this is the part. Sorry. So strength, this is the this is the particular cement, and this is the strength. Strength is A, and workability B. So if you add cement, then what happened here, the strength will be more. The strength will be more than A. However, the workability will be B. There will be no change in workability. If you add both water plus cement, it will strength will same because you are not increasing the water, you are not destabilizing the water cement ratio, W by C ratio. So strength will same. Sorry. Strength I think I crossed the limit somehow. So so this is strength is A and workability B. If we add cement, strength is greater than A, workability B. If you water plus cement is there, then strength is A. There will no change in strength, but workability will be increased. Workability will be increased. Workability will be increased because you are adding more water. Now, if you add the admixture, what happened? If you add the admixture, what happened? There is three possibilities there. If you water reducing admixture you add, plus you reduce the water, and reduce the cement, so water cement ratio is same, then what happened? Then strength will be same, workability will be same. So workability will be the strength. There is no change in strength. The workability will be change in workability. Now, if you do one thing, what if you add water reducing agent and reduce the water content only, no reduction of the cement. So water reduce it will get down. Water cement ratio will get down. What happened? The water will decrease. So strength will be more. Strength, you can increase the strength, however with the same workability. So with that you can save the cement. You are not adding the cement, you are decreasing the water. With the addition of the WRA, you are getting the strength more than A, and also workability B. Now if you add this and you only add the water reducing agent, what happened? No change in water cement ratio. Nothing you are adding, or nothing you are subtracting from water or cement. So only water reducing agent you are adding. What happened? The strength will be same, however the workability will be greater than 0. So with this it shows that if you add the water reducing agent, that is also a type of admixture, you will get the strength, you will get more strength without increasing the water content. Or you can with the same strength, the workability you can increase if you add more water. So this is the fineness, or this is the um, characteristics of the water reducing agent. There are also administered like retarder, accelerator. See, these are all the theory part. You can go through all the theory, and also you can find some notes. If I have some notes, I'll make it for you, so it will be easy for you to go through all these things. So I think I am sorry for not discussing the MCQ part, because there are more content today, and I think it will be good if I discuss those points. I'll discuss this MCQ type question, because that will be beneficial for you in performing better in competitive exams by coming sessions, coming classes. So thank you for attending. So thank you. If you have any question, please ask me. So thank you everyone. Thank you. Okay. Thank you. Good night.